to start? All right. All right. Hi, everybody. I'm EG. I work at Infura. Over here also is Chris Shin. We're going to be presenting today on Infura and Web3 infrastructure. So I'm going to start with sort of an overview of Web3 infrastructure and exactly what that means through the eyes of Infura, running nodes as a service, Ethereum APIs, and other incentivized protocols that we've dealt with. And then Chris is going to finish up the talk today talking about an initiative that we started recently, which is a GraphQL API for Ethereum called EthQL. All right, so what is Web3 infrastructure? We're on day 3 of EthCC now. A lot of the talks here have dealt with everything from application layer to layer 2, scalability, user experience. The thing that's really interesting to us is the actual infrastructure in the traditional sense that powers this, whether that's Ethereum clients or the underlying network protocols and things. So that's what we wanted to discuss. The way that we see it is that there are layers of Web3, kind of similar to the OSI model for traditional networking stacks. But here we're building applications as decentralized applications, right? And then below that, you have the base protocol that powers these Web3 decentralized applications. So whether you're building that on top of Ethereum or whether you're using Ethereum plus IPFS or some other decentralized storage, or you're pulling additional decentralized components into that, like ENS for usability and things, there's a lot of things that go into that base layer. And then below that is the peer-to-peer layer. So part of these decentralized distributed systems is being part of this peer-to-peer network. And I gave a talk at the Gurley conference back in January talking about the peer-to-peer layer for Ethereum. And that's what I wanted to talk about a little bit on later today. So below that is also the physical infrastructure. And by physical infrastructure, I mean the actual traditional web infrastructure that we still run on, whether that's data centers or Amazon cloud instances. So when we're talking about the application layer, we have these utility tokens and other application layer protocols, and we don't always associate that with infrastructure because maybe it's something like you have Aragon tokens and you're doing things with the Aragon platform, but you don't need to run anything necessarily. You can use the application, but it's not really what you would consider infrastructure. But you start to get into that infrastructure world when you start to look at things like LivePeer, which is like an incentivized transcoding system or platform, or other things like Golem, storage, Raiden, Filecoin. Those types of things require you to run additional clients. And that's something I want to touch on a little bit later in this talk when I'm talking about the incentives to participate in these systems. Below the application layer is that base layer, like we were saying, the protocol. Not going to spend a lot of time talking about that. There's plenty of talks here talking about ETH 2.0 and the things on that roadmap. At 4 o'clock today, there's a session that Boris is putting on the ETH 1.x roadmap. If you guys haven't been paying attention to the things that came out of that 1.x workshop that was in California, I think it was January, you should attend that talk. There's a lot of really interesting things going on at that layer with how Ethereum's going to be scaling in the near term while research on 2.0 is ongoing. This is the layer that Infura deals with most regularly, which is the nodes, the Ethereum clients. And if you're running your own Ethereum client, you're probably running one of the 2 most popular flavors, which is Geth or Parity. But client diversity is really great within Ethereum, and we have a lot of different clients that people can choose to run. If you wanted to be able to customize your own client and you're more interested in working in like an Elixir code base, you could look at the Mana Ethereum client that Compound and POA Network and a bunch of others started work on initially as the Ethereum project, and now it's called the Mana Ethereum client, and you could participate in contributing to that. The Pantheon client is like a Java enterprise client that Consensus and the Pegasus team released a 1.0, I believe it was just last month, and so that's mainnet capable, and you can run that client as well. So one of the things to consider when you're talking about running infrastructure, so say you're going to start a decentralized exchange or a traditional exchange or something, your back-end systems may still require running your own nodes as like a traditional business, whether it's for your own personal accounting or additional APIs that you want to provide on top of that. And understanding which clients are available for you to run is important, and then understanding the governance of these different projects and how to collaborate with them is also important at this early stage of the ecosystem. So if you have a question on are they going to be able to add this particular functionality that'll be really useful for your application, who do you talk to right now? And it took us a long time to figure out what was the right way to kind of get access to that information and have those conversations. And it's difficult and time-consuming right now. You see a lot of that come up around these hard forks for Ethereum and a lot of the cross-client team development coordination that needs to happen. Some of it happens on Gitter. You see these conversations on Twitter, and it's decentralized and inefficient, but by design. So if you want to start contributing to these projects and taking part in these discussions, looking at the ETH research boards, follow the developers on Twitter and get into their Gitter channels or Discord channels. The node infrastructure is what these clients actually run on. So some of our friends from DAppNode are here, so you could run DAppNode and have that manage your client for you, whether you're running DAppNode yourself on your laptop, or if you're putting that on your Avada server or some other type of like specialized client device. That's one option. You could be running this as like your status light client on your mobile device. You could be running this through your VPS, which I think majority of people do, whether that's DigitalOcean, Linode, Azure, AWS. And then lastly, people could be running their own physical server somewhere, whether that's co-located in a data center or through some other like bare metal provider. But those are pretty much the options that you have. And so talking about the physical infrastructure, we're building these decentralized applications through these peer-to-peer clients, but then the centralization still is there when you start to talk about the physical infrastructure. We're still in these centralized data centers, and you're still running on the same fiber backbones that everybody else in the internet is running on, whether you're Venmo or Twitter or your Filecoin. So when you're talking about decentralization, a lot of people talk about decentralization as if it's like, it's very clearly defined, like, yeah, it's decentralized, it's great, but there are many flavors of decentralization, and decentralization is a spectrum. So I think it's valuable to talk about decentralization in terms of what aspects of decentralization is your product or project focusing on. Are you enhancing privacy? Are you enhancing security? Are you more capable of surviving like network faults and things like that through redundancy of the peer-to-peer network? And you don't necessarily need to check all boxes as long as you and your users understand the trade-offs that are being made. So with that, let's talk about the current state of Web3 infrastructure. The current state of Web3 infrastructure for Ethereum is that our underlying peer-to-peer protocol is called Dev P2P. It's a combination of the discovery of how your client, when it starts up, connects to nodes on the network, and then the Ethereum sub-protocol built on top of that that defines how that data is shared, whether that's you submitting a transaction and it propagating across this network, or whether that's how your client receives new block information and keeps in sync with the network so that you can participate in it. It's really difficult to understand the health of the network because you really have to kind of have this centralized point to understand the state of the network. And for the longest time, the source we went to as a community was Ethernodes, and that was the source where we could see how many nodes were currently running, what clients were running, were most of them up to date. But that was pretty much it. And so earlier this year, we started developing this tool that we called just the Dev P2P network tool. And it was a Dev P2P crawler built on top of the Ethereum JS Dev P2P client. And it's fairly straightforward. It connects to the network and it indexes information as it encounters new nodes, basically a dev P2P crawler. And what that allowed us to do is, track historical state of the network. If I went to Ethernodes or some of these other websites right now, I could see the current state of the network. But what's really interesting to see is as our community continues to grow is what was the state of the network 2 months ago, or what was the state of the network before and after the Constantinople fork. How were people typically upgrading their clients a week ahead of time or the day of? And that's stuff that can help developers better inform their release cycles and how they communicate with the community so that people have time to upgrade their clients. Back in 2016 with the spam attacks on the network, people would release, the client development teams would create a release, and the community was still small enough that people knew where to look for that information, grab the latest binaries and update their clients, and we sort of had to keep the network up and running. But as the ecosystem in our community continues to grow, that information is going to get harder and harder to disseminate. So having these tools, and people should be developing more tools, will allow us to understand the health of the dev P2P network. So one of the places where we see issues with the peer-to-peer network arise is on our test networks because they're smaller. The most common issue that we encounter is that because of the low hash rate on the proof of work testnet Ropsten, you run into various issues. Early on, there were attacks on Ropsten because of there being such a low difficulty on the network that someone was, initially nobody was actually putting GPU miners on it because it wasn't the best use of their hash power. There was no incentive to do it, and so somebody came along, started mining Ropsten blocks, taking that ether and spamming the network. And so people had to start GPU mining, and for about 1.5 years now, people have been using GPU miners on Ropsten. But then we ran into an issue again with the preparations for the Constantinople fork because nobody was actually paying attention to keeping their clients up to date because maybe they had migrated their test applications to Rinkeby or some other testnet, or they were just kind of leaving this thing running, they forgot about it, and it was still mining with an old version of the client. And so what happened is after the Constantinople fork, we were left in a position where we were constantly getting chain reorgs, and as Infura running a shared endpoint to give access to this network, people are reporting issues saying, my transaction's not showing up, my transaction's not getting mined, I'm getting inconsistent information. And it's not something that we as Infura can fix. Like, people see us as a traditional service that can provide traditional support, but it's complex because we're providing support for a peer-to-peer network that isn't really in our control and shouldn't be. And so the best thing that we can do is kind of share that information on what's happening with the network so that other people can participate and help fix it. So in this case, with the Ropsten network, we reached out to people from the foundation. They started running updated miners, and we were able to get the chain back onto the Constantinople side of the fork. Some other networks, Coven, Rinkeby, suffer from similar issues of there just being low amounts of nodes. Most people don't really run those nodes at all, or they don't run them consistently, only really when they need to. So we can say that people should be using light clients to connect to these, but if you try to use a light client to connect to these, it's hit or miss whether or not you're actually going to peer and be able to sync it quickly. And so I'll talk about light clients a bit later, but it's one of the issues to be aware of. So this is why I'm really a fan of the Gurley Testnet initiative. I've been following it since the beginning when it first started at ETH Berlin, because the community passion behind it is really pushing for it to be a reliable test environment. If you guys are going to be building any applications on a testnet and maybe redeploying your application on a testnet, I would highly encourage you to consider using Girly for that. It's like the most actively maintained testnet right now, in my opinion. The community behind it is really excited about it being the first like multi-client supported testnet, so you can run Geth, Pantheon, Parity, Nethermind, and anything that supports the Click protocol can connect to this testnet. One of the reasons why Girly is also so great is because it was just recently reset at GurleyCon in January, and so it's really fast to sync. Infura added support for Girly yesterday, officially, so girly.infura.io, you can point your RPC client to it and immediately start using Girly, but you can probably sync Girly faster than it's going to take me to get through this slide right now. It's going to take you like 2 minutes to sync a node on Girly, so you should do it, and also enable light client support for it. One thing to note with that is that if you're using light clients, Parity's light client will peer extremely quickly because Parity nodes support an alternative light client protocol that is enabled on Parity nodes by default, so that and you notice that difference versus with Geth and other clients. You have to, if you're running a full node, you need to explicitly enable serving light clients, and so that creates this dynamic where Parity light clients can immediately peer and get synced pretty quickly, and the LES Light Ethereum subprotocol clients that Geth supports take a little bit more and aren't as quick to sync. So talking about state growth here, there's some stuff coming out of the 1.x workshop. So both Vitalik and Alexei and a few others have been talking about proposals for state rent. So the current Ethereum state, depending on which client you're running, is roughly around 2 terabytes, 2.1 terabytes right now. And you can look on Twitter about whether that's FUD, whether people care about state or should care about state or should be able to survive off of a light client. And regardless of the specific details of that, there are people that do need the full state for their business use case, whether that's looking at historical balances from 2017 and things like that. We should continue to try to make it easier for those people to not have to wait 3 weeks to sync a full archive node from scratch if they need to. The other thing that's relevant to this is the state snapshots that are generated. So warp sync with Parity. There's been some discussions around how that could be improved and how this state bloat is making that less and less feasible. So in this 1.x workshop later today, I'm interested in hearing more about the current developments on that, because getting people to keep their clients in sync is really important for the health of the network. And then all the client teams are constantly looking at storage optimizations, database optimizations, things to optimize disk I/O so that the network, or so that their clients can continue to keep up. So then talking about light clients and ultralight clients, I already talked about the Parity light client protocol. LES is the sort of standard flavor that Geth supports. There was a talk, I think, earlier today from Christoph from Slockit on Incubed as an alternative, like IoT-focused light client. And then Mustakala is something that the MetaMask team was working on and is still continuing to work on, which is like a browser-enabled light client using sharding the state and propagating it through this peer-to-peer network of browser-enabled clients. Some of the R&D efforts around this. So we're a member of this constrained resource client group. It's a group that's really interested in looking at the problems of the current light clients and how to improve the usability of them. And the paper that we came across recently was from a few people from Stanford, Kyber, and Visa on the Fly client. If you haven't taken a look at this paper, I recommend that you do. It's an alternative to an SPV light client that reduces the bandwidth requirement significantly, but requires a hard fork to introduce some additional information, Merkle mountain ranges, into the block headers. So with light clients, so there's roughly 1 million downloads of MetaMask. If people here are using MetaMask, and if MetaMask tomorrow switched over to being a light client, would there be enough full nodes and light client servers to be able to support that demand? That's up in the air and probably not likely unless we do 2 things: get more people running nodes, or get light clients more efficient. And so this full node incentive problem is something that we started looking at back in 2017, and we felt like we could create a protocol that would allow people to earn tokens or earn ether to be able to serve light clients in some form, but we didn't feel like there would be enough demand for that. It'd be like we'd create this protocol and then nobody would actually use it because it's still going to cost them $200 a month or take up too much of their MacBook's hard drive space to be able to do that, and they wouldn't be incentivized to. We came across several teams, VIP Node and D Node, that were working on very similar approaches to that and decided to primarily help with the VIP Node project. So if you're not familiar with VIP Node, Andre, who's in charge of that project, recently released VIP Node 2.0, which is a way for you to deploy a VIP Node pool server that allows you to have light clients pay to peer with your VIP node. So it's one approach. Some of the dependencies that we had for incentivization were how do nodes basically do micropayments between each other, and we were looking at layer 2 solutions for that weren't necessarily mature enough. And how do these nodes exchange information on other nodes, and the sort of reputation of these nodes. So like, do I want to peer with this node? Are they able to keep in sync? And how much should I be able to pay that node? And we said maybe we could use the Whisper protocol for something like that, but it wasn't there yet at the time. So talking to these projects is interesting. I haven't talked to anybody from Incube, but if anybody's here, I'd be really interested. And the goal of this full node incentivization is to at least recoup some of the cost of running this infrastructure so that we can continue to help onboard new people into the ecosystem that don't have the technical ability, the resources, or the interest in running their own full node. Incentives are interesting. So I like using BitTorrent as an example because it's the most successful peer-to-peer network that we have. And there isn't this incentive problem there, because the incentive with BitTorrent is the content, right? So if you want to get on BitTorrent and download, the Linux distros that I have listed here, or maybe what other content you want to get off of BitTorrent, you have to run this client, and the content is the incentive. There's no additional monetary incentive required. But with running an Ethereum client, the incentive is not the data. You don't care about the data. You care about the functionality of participating in this network. So as long as you're able to participate in this network, you don't care about if you're propagating information to somebody else. And this is the two-sided market problem of incentivizing people to run full nodes, is you can create this incentive protocol, but it's too expensive for people to run nodes, and then nobody's really interested in paying for something that they haven't even tried yet. Right? And so I like to use Uber as the example. Some people don't consider Uber a pure two-sided market, but just bear with me with that. That if you have all of these drivers but no riders, then you're not going to have drivers and they're going to go to some other platform, right? And that's the kind of problem that in Infura we wanted to try to help solve here, is bootstrap the user side of this. Enable people to explore Web3 through Infura and MetaMask and all of these other easy on-ramps into the ecosystem. Try to solve some of that usability and UX from both the developer and the consumer side. If you guys didn't see Taylor's talk earlier on just the pains of getting on board into the ecosystem, you should check out the recording. But the incentive protocols need to be given the chance to succeed by being given a market of people that are willing to pay, because they tried out this ecosystem through these simpler access gateways and are ready to participate in these incentivized models. And once we get to a sufficient size, I believe that these incentivized systems will actually self-activate, because people will see the value of it and begin to participate in it. So the growth of the ecosystem is kind of an example of that. So this is a graph of Infura's daily traffic back when we were only at like 1 to 4 gigs, or 1 to 4 billion requests per day. Towards the end of 2017, this was the CryptoKitties spike. So somewhere there at the beginning of December, there was this huge spike in people trying out CryptoKitties through primarily MetaMask and Infura's access to Ethereum. If all of these people had to install an Ethereum node, wait for it to sync, or if all of these people needed to run a light client, it's unclear whether or not CryptoKitties would have had as much success as they did during this time. So our goals are to help the onboarding experience of these end users, whether they're consumers or developers. And our commitment to the ecosystem is to maintain an API that's compatible with the open source clients so that people can use Infura and continue to run their own node and switch off whenever they'd like to. And then we constantly try to share our learnings on running this infrastructure, primarily through our Twitter account. So if you're not following us, you can follow there, and we like to share blog posts periodically to help people run nodes and optimize their infrastructure. Some of the other improvements to the ecosystem, again, lowering the cost to run a node. Alexei Akhinov's been working on this TurboGeth project, which is sort of reimagining how the state storage and database storage for a client should work. And we've been helping support him through funding as well as testing. We upstream client optimizations whenever we run into performance bottlenecks. We've been funding the support, funding the research and development of VIP node. And we participate in the JSONRPC standardization so that we can standardize on RPC responses for errors. And lately we've been working on this GraphQL API that Chris is going to be talking about. So going into that, the JSONRPC is a very lightweight specification. There's really not much there. It's not like a true spec, which is why EIP 1474 is trying to define that clearly. And it's really just a thin wrapper over what you would like to do with the blockchain data on disk, whether that's grab a specific section of the tree data, look at specific transaction hashes and things like that. It's not a query language, and people are building these applications as if the JSONRPC is a query language. The data relationships aren't exactly clear, and people that are entering the ecosystem for the first time are constantly referring to either the JSONRPC documentation or going back to the yellow paper to understand how to use this API. There's also this problem of overfetching and underfetching data where maybe you're trying to query for presenting data for your wallet, and you need to know the account nons, account balances, maybe token balances and things like that. And that's going to take you dozens, if not hundreds of API calls, when really with a better API, you would do it with fewer. And you end up overfetching a lot of data, getting redundant data and things that you don't necessarily need or care about. So the lack of the definition in the current JSONRPC implementations is why EIP 1474 is valuable. And it'll help clear up some inconsistencies around 0, 0x, 0, or 0x types of things that occasionally create bugs on the client library side. So with that, Chris is going to talk a little bit about EthQL and this GraphQL API for Ethereum.
All right. So just as a quick poll, I'm curious, how many people have heard of GraphQL by a show of hands? Great. And how many people have used GraphQL in a project? Nice, okay. So I'm going to go over a little bit about what GraphQL is, how it relates to Ethereum, and some of our findings around some early tests and kind of where the space is headed. So for those of you that are unfamiliar with GraphQL, it was a API specification originated by Facebook. Back in 2012, they've been using it internally. They open sourced it in 2015. It's had a MIT license applied to it in 2017. I think the problem that they were really trying to solve is how to make the API calls more efficient, right? They were moving very heavily into mobile. Mobile is a constrained network environment, so how do you create an API that can quickly and efficiently serve mobile clients? And so they started coming up with this GraphQL. What's nice about it is it's a very, it's got a very complete specification. It's strongly typed, self-describing. It has query validation built into the spec. So a lot of the things that you do as a server developer, of all the validation and all of the queries coming in is already taken care of for you by the spec. The big twist is flipping the paradigm of how data is selected, right? Traditionally, as a server developer, I would say, these are my data resources, and I'm going to expose them to you, say, over a REST API. So I'm going to give you the entire record or the entire document. And so there are always server-specified data returns, which left the application developers with the problem of, okay, so I need to get this resource, but I only need 2 fields out of this document, and then it relates to this resource over here, and I need 3 fields out of that document. And after you're building your front end, you end up making a whole series of web calls and processing all of the data in order to render your front end, right? So GraphQL flips this and makes it client specified. So GraphQL defines, okay, this is all the data that's available and how it's related. And then the client specifies, okay, so I want this piece of data, this field over here. It relates to this data object over here, and I want that one field. We'll go into a little bit of what that looks like. But the important thing is it gives the power to the clients versus being wholly specified in the server. Additionally, you get a lot of niceties of there's sort of out-of-the-box solutions for paging, versioning, deprecating, and extensibility. With regards to sort of the operational aspect of GraphQL, there's 3 major operations. There's queries, which are read-only operations, mutations, which are write operations, and subscribes, which is basically like push messages, push notifications. Long-lived sockets, like think a WebSocket or a long-pole HTTP, where you're getting pushed information that you're subscribing to. It supports variable substitution, so you can reuse queries. You can create a query tree and just parameterize the variables in there so you can reuse your queries. And it supports fragments, which I'll get into a little bit later in the talk. So why do we want to use GraphQL? The summary is that getting data off the blockchain is hard, right? JSONRPC is not a query language, so very simple use cases or things that you might want to do in an application are kind of hard to do in JSONRPC. Like get only the transactions related to my contracts, list all the addresses that sent transactions in the latest block, show all the token transfers in the last block, tell me all the ERC20 symbols that were traded in, block X. All of this requires multiple calls over JSONRPC, compiling the information, filtering it down before you can display it to the user. The other reason why is because any data, especially Ethereum data, is graph-oriented, right? All data is sort of relational to one way or another. And so what I'm showing here is kind of a simplified view of Ethereum data. Block data, transaction receipts, logs, accounts, and how they're all related. There are disparate data types, and there are relationships, inherent relationships within them that it's not reflected in a resource-based API. So why GraphQL? Better user experience. It helps solve that problem of overfetching or underfetching data. It's less data over the wire, less round trips to the server. It has better support for constrained environments like mobile, since it was built with a mobile-first ethos. There's a strong ecosystem of tools that support the developer experience, right? So if you think about JSONRPC, there's very little tools that actually support the specification. That's the kind of stuff that we as DApp developers use are things like Web3, ethers.js, those kinds of things. But there's actually not that many tools that support the developer experience aside from that, like an SDK layer. And it's easily extendable. So the current state of EthQL has been developing pretty rapidly over the last year. A little over a year ago, Raul Kripliani came out with EthQL as a sidecar application, right? Skin over the JSONRPC that exposed a GraphQL interface, believing that GraphQL was a better way to get Ethereum data. A few months pass, and Nick Johnson also starts looking at GraphQL as a way to query out of a node. Eventually, Infura Nick Johnson, Raul, they all got together, found that we're all working toward the same end goal, and started collaborating on trying to create a spec, an EIP. So where the ecosystem, or where this area stands right now, is that we've just opened up an EIP for comments, 1767, and it's focused on basically equivalence with the JSONRPC from the node perspective. It's focused on simplicity and efficient access of the internal data stores, and there's a POC currently implemented in Geth on the master branch. If you pull down master and build it, there's a -- GraphQL flag that you can enable the GraphQL interface. On the other side, as a layer on top of the standard flavor, is EthQL extended, and this is Raul's original project that lays on top of that base layer and extends it with additional higher level application-centric use cases, things like transaction filtering, log decoding, storage decoding, things that are useful for more of an application perspective. So it's deployed as a node sidecar, so it attaches over JSONRPC or IPC, WebSockets, HTTP. It supports log decoding, ENS address resolution, like I said, X-ray functionality into storage, transaction filters, and it's built with an open plugin architecture so that you can add support for your own custom contracts or ERCs that you're most interested in, so it's easily extendable. This is a bit what a GraphQL query looks like. I hope it's legible. So basically on the left side, we have the actual query. It looks a bit exotic from maybe other query languages. On the right side, you have the resulting tree, the resulting set. What's important here is that there's equivalence. The shape of the data on the left side is the shape of the data on the right side. So the clients know exactly what they're getting, what to expect. The other thing that I wanted to point out here on the left is the use of a fragment. So that's sort of what fragments look like. Basically, you can inline internal data structures. And then on the right side, you can see an example of what log decoding looks like. Rather than just seeing the raw data, you're getting the transfer, the symbol, which accounts it's going to, value, etc. So we were running some tests early on in the project, and the test was set up like this. We wanted to fetch 5 blocks, and from those 5 blocks, we wanted to get the block hash, the sending address, the value of every transaction, and for each sender in those transactions, get their balance, right? So if you think about this from like a Web3 implementation, you're basically looking at 2 sources of data, right? The block data, a get block call and a get balance call. Put into the context of EthQL, it creates a query tree. So back to the diagram that the simplified diagram that I put up before, this is the part of the tree that it's going to be querying. And the left side is what it looks like in the GraphQL syntax. The blocks range from start to end, block hash, transactions, and value. It's easier to see here, but the data relationships between blocks, transactions, and accounts are a little bit more apparent the way that they're nested. This is what it looks like executed. So what this is showing is the parameterized queries that I was mentioning before. So this is the same query, block range hash transactions. Sorry, let me go back. Nope. There we go. Parameterize the start and the end blocks. Otherwise, the transaction is the query is still the same. The parameterized definitions on the bottom there, and then the shape of the data again reflects the shape of the query. So the results of this, doing that query over JSONRPC was a little over 1,842 calls, right? For each of those 5 blocks, there's a little over 300 transactions, and so you have to loop over each of those transactions to get the balance. In EthQL, that's a single call. The response size that you get over JSONRPC, the overfetching problem, is a little over a mega data returned. In the EthQL version, it's a little over 200K. So the efficiency gains of EthQL over JSONRPC are pretty immense. Looking at it from more of a node implementation side, the data selection gives you increased efficiency because of omission of data that's not requested. So total difficulty is an example of this. Total difficulty is a data field that's not stored in the block header, so it's a separate disk read in order to return it in the block. So if you call a get block, it returns total difficulty, total of at least 2 disk reads to return that data. Well, most clients don't really even use total difficulty. So if you omit it, it's a disk read the node doesn't have to make to return the data. Additionally, receipt accesses have a much more efficiency. So it's common to say, okay, for every transaction, give me all of the receipts for these transactions. The way that you have to do it over JSONRPC is through the get transaction receipt call. You supply the transaction hash, the node will pull that data blob, deserialize it, index the hash, and send it back. So you're talking about, if you're enumerating every transaction, it's an n-squared data access. That gets simplified to an ON data access. So there's a lot more dramatic efficiency gains there. On the application side, there's improvements because you're reducing the network payloads, response deserialization. The response in the application is in a defined shape, so it's easier for the application to reason about what's getting returned. And it's a better model for decoding raw data. Rather than keeping it in the application, you're syncing a lot of that decoding into a server layer. Basically, the upside is that less loading time in the application is a better user experience. So what's next? We're working on finalizing the EIP 1767. If you're interested in this, go on, comment, give your feedback. It's still open for comment. There's additional EIPs covering more higher level subjects such as subscription standards, more functionality. On the EthQL extended side, we're looking at more log decoding, so supporting more standards, more ERCs, building better tools for developers to use more their custom APIs. And there's also an initiative for client libraries. So if you didn't want to use the EthQL sidecar, you didn't want to run an application server, it's syncing all of that functionality that the server does into the client side, so then you can connect directly to a node and have the benefits of EthQL directly in your application. Additionally, for those of you that are sticking around for ETH Paris, we're going to be doing a workshop on Saturday as well, diving into EthQL and how to build with it. So definitely check that out if you're around. And that's it. Thank you. Anybody have questions?
With respect to alternatives like the graph, how this would compare?
So the graph is focused on event data almost explicitly, right? So they're indexing the event data. This version of GraphQL, the EthQL, is really about interfacing with the node. So for example, one thing that you can do with EthQL that you can't do with the graph is send raw transaction. It's also very Ethereum specific, where I think the graph is trying to create more of an overarching chain for index data.
So I imagine that if you make it more queryable, then either you've rearranged the data or you've duplicated the data. And can you just talk about, does this increase the size of the data on the disk for the node? And is it optional, or is it something that would be built into every client?
There's a lot to unpack. So it doesn't really affect the storage of data on the node. What it's doing is moving the aggregation of all these calls on the node. So there's no increase in data size. It's just more of how it's accessed and packaged before returning it to the user. Comparing it to JSONRPC, you have to do it through separate calls. GraphQL is sort of taking those calls and wrapping it up in one transaction or one interaction. Second part of your question, sorry, can you? It is optional, yeah. So the EIP that we're trying to get put into all of the clients, currently supported by Geth, but we're trying to get it into Parity and Pantheon as well. It is an option flag, so the way that it's implemented in Geth, much like the RPC, the JSON RPC, you have the RPC flag. There's a GraphQL flag that you can use to enact it.
Hi, thanks for the talk. So, do you have support for efficiently querying historical aggregated data for accounts or for contracts?
Aggregated. By aggregated, you mean like indexed, like specifically indexed, or?
Yeah. So if I want to query like the entire transaction history for an account or for a contract, I expect that to be pretty heavy computationally because it would need to run through the entire chain up to date.
It would be. So right now, indexing is definitely something that we're looking into building in. Right now, it would look more like sort of a chain scan or a block scan, where you're trying to filter down the return data on those particular contracts that you're interested in, but you would still have to scan the blocks to do it. Well, thank you very much.